Hello grade 11s. Today we're going to talk about quadratic equations, and then we're also going to talk about how do we find the solutions, or what we might call the roots, for all quadratic equations. So let's start with the idea of a quadratic expression. So what is a quadratic expression? Well, quadratic essentially just means a algebraic term with a power of 2, or with the highest power of 2. So that could be a quadratic expression. Something like this could also be a quadratic expression, and something like this could be a quadratic expression. So anything with a highest power of 2 is going to give you a quadratic expression. So what is a quadratic equation then? So it's just a slight modification of the original idea I expressed above. So I'm going to now take something like that term and just make it equal to 1. So that's a quadratic equation. Or I could say something like this is a quadratic equation, or something like this. So you're basically just knitting together two expressions with an equal sign, and we would say that the middle quadratic equation is in standard form because the right hand side has a 0 and all the terms are on the left hand side, all the other terms are on the left hand side, and they're written in descending powers of the variable. So that's all a quadratic equation is. So then, if we have to look at grade 10 quadratic equations, they would look something like that. And if I had to ask you what is the solution to that equation, quite a few of you could do that by inspection. So you could just say, well, look, I can clearly see that x is 1, and then some of you would even say, hold on, there's actually two solutions here. There in fact, x is equal to minus 1 is also a solution. And you can see that because if you put minus 1 squared if you put minus 1 into the equation and you square it, you get 1, which makes the statement true. Another way of seeing this is if I just square root both sides, I'm doing the same thing to both sides of the equation, and when I square root on this side I get x, on the left hand side I'm going to get plus and minus 1. And so quadratic equations can often have two solutions. Now let's look at another example, a little bit harder. Now this sort of thing you wouldn't have seen specifically, I don't think, in grade 10, but how do you think we would solve this? Well, first of all, let's try and factorize the left hand side. So if I factorize it, this has a coefficient of degree 1, so I think that I could just say that that's x and that's x, and then I'm going to look at the factors of 10 and go, you know what, I think a 5 and a 2 would do quite nicely, and a minus and a plus here. Now, from inspection here, I can see then that the only value of x that makes the statement true is going to be, well, if x is 5, then I know that 5 minus 5 is 0, and 0 times anything is 0, so 5 must be an answer. Or I could say x is equal to minus 2 in a very similar way that I solved the previous, because minus 2 plus 2 is 0, and so on. So that's me solving a quadratic equation, and a more difficult one. And if I had to classify the solutions or the roots, I'd be having a closer look at these things. And from what I know of classifying numbers, the number 5 would be an integer, the number 5 would be a rational number, the number 5 would be a real number. And we could do a similar idea with x is minus 2. So we can talk about the roots of the equation and what their nature is. How do we classify them? So now, if I move on to something like y squared equals, or y squared minus 7, how would I solve that? Well, I'm just going to move the 7 to the other side, and if I do that, I could square root both sides, and y would be equal to plus or minus square root 7. Now, this is definitely a quadratic equation because the highest power of 2 is, or the highest power of a variable is 2. But when I look at the actual roots of this equation, or the solution, there's something a bit different. Is this plus the square root of 7 or minus the square root of 7, is that an integer? Clearly not. Is it even a rational number? It's actually not. And if you take your calculator out and press square root 7, you'll see that it's quite a messy pattern of decimals, and it actually goes on forever. And so we would say that this particular solution is actually an irrational number. Now that's interesting because it shows you the different types of roots for quadratic equations. So let's move on. So what does a grade 11 quadratic equation look like? Well, let's look at that. Now take a moment and think about how would I actually try and solve that? Well, using the idea that I just did above, I'd probably do something like this. I'd go, well, I'm going to try and factorize it, and I'm going to go x is here and x is there, and now I've got 5, and look, 5 is a prime number, so I can put a 5 and a 1 there, and now I go, but hold on, there's no way to get 1 and 5 to balance off to get me minus 3. And so in fact, I'm stuck. I could put minus minus, that doesn't work. I could put minus plus, that doesn't work. And I could try a couple of combinations, and I realize I'm actually stuck. And so this is the thing that we're going to talk about in grade 11, is how do we solve a quadratic equation like this where we can't easily factorize it. So how do we do it?